take work, energy and power. This topic which I am going to start today incorporates two different kind of chapters. It brings the conclusion from two different chapters. Okay, the first one is we'll see that we are continuously using the word, the things of kinematics. Okay, and then we'll see that there are also some concepts of NLM. Now, why this chapter was brought? This chapter was brought to talk about these two topics in a much more easier way. Got it or not? Means work, energy, power helps you to define kinematics and NLM in much more easier way. That's what this subject deals with. Okay. Now, here there are three words: work, energy, and power. Now, what is they? What are they? We are going to talk one by one of on each of these factors. Okay, but before that, the first thing which we want to define specifically is the topic called as work. So question arises, what is work? Okay. Okay, what is this word work? To talk about this in much more detailed sense, simple idea is there. Let's suppose there is a block of mass m. I placed a block of mass m on some ground and I applied some force on it. Okay, I applied some particular force on it. Now what you are going to observe that, let's suppose I applied some force like this. Is that clear or not? Now this block is, let's suppose, making some angle theta with the horizontal, right or not? And this block has a mass m. What happens that when I applied this force, irrespective of whatever thing is there, this block slides a little bit towards right hand side. Okay, it starts to slide. Means this particular force, which you have considered has started to bring some physical change. What is that physical change? Sliding of a body along horizontal direction, movement of a body. Means this force is bringing a movement. The measurement of this particular thing, the measurement of this movement of the blocks with respect to the force applied, and that measurement which we do is basically called as work. Now one condition is there, that we select work as defined as force along displacement into basically displacement of the body. Is that clear? Means you think, you imagine like this way, like let's suppose there is some person is standing over here and there is a big almirah over here. He's trying to push it, right or not? So basically this almirah will slide. This means that this person has done some work. Are you able to get me or not? So work is nothing but a measurement of what physical change external force is bringing, even internal forces whatever are bringing. Is that clear or not? Even you can think like this. See, let's suppose there is a bomb, okay, and it explodes. It will explode and it will break into this many fragments. So here, from outward there was no force. There were some chemical reactions which happened and they generated force in all these directions. So of course these forces, all these forces are also doing some work on each of these particles. Then only these particles are doing some physical change. Are you able to get me or not? Got the idea? So this is the meaning of work, that what physical changes, measurement of a physical change created by force along the direction of displacement. Are you able to get me or not? So let's suppose this force, how much force is present along the displacement? If you look into that, it has a magnitude F cos theta. So basically work is given as F cos theta into this displacement. Is that clear or not? Now anything we know that this quantity, we say that this is a scalar quantity, okay, and this is a vector quantity, and displacement is also a vector quantity. So to, as we can know that there, if there is a product of two vectors and I got a scalar quantity, basically we write this in the form of vector law, and we say that basically work can be simply written as work done can be simply written as f vector dot displacement. Is that clear or not? Are you able to get me? Now question arises, sir, are we going to always take force along the displacement? To talk about this in a detailed sense, I take another example. Let's say that, let us suppose that there is a sponge kind of material kept on this surface. Go ahead on. This is a sponge material. Are you able to get me or not? Or let me just draw, let me take a shape over here. Okay. So there is a sponge shape material over here which has a mass m. And on this sponge, what I'm doing is I'm applying some force. Go ahead or not? Is that clear? Let's suppose I applied some force F over here. Now when you will apply this force over here, what you are going to observe? This is a sponge basically. What you are going to see that instead of all the particles traveling along right hand side, what happens? It creates a curve something like this. Means it will be something like this. What up? Means it tries to penetrate this sponge. Are you able to get me or not? This means that the mass is like this. These are the point particles which are traveled along these directions or not. Say me something, yes or no. So question arises that when you apply this force, if you want to consider the displacement, which displacement are you really going to consider? Are you going to consider this one, this one, this one, this one, or this one? Now there is a big confusion, sir. How to define the displacement over here? There are so many displacements, so many particles are moving here and there. So during that scenario, in such scenarios where your work is uniform, where is force is uniform, but the displacement is variable, then what you are going to do? You are going to write that work is equal to nothing but force into displacement along the point of application of force. Force into what? Displacement along the point of application of force. Are you able to get me or not? Say me something else. Clear? Clear or not? ठीक है. हरिओम, और लोग कहाँ है वो सब हमारे जो दो तीन लोग रहते हैं? कहाँ है सब? आज नहीं है क्या? अच्छा, सो रहे हैं सब. ओहो, ये बात. ठीक है, कोई बात नहीं. तब ध्यान से देखो. ये हो गया अपना का अपन वर्क का डेफिनेशन. दिस इज द डेफिनेशन ऑफ वर्क. टू डेफिनेशंस आर देयर. वन इज फोर्स अलोंग डिस्प्लेसमेंट. Another one is force into displacement along the point of application of force. Both are correct only. There is no problem which in which you can consider. Okay, both are correct things. Okay. Now, so when we are considering this, so question arises that, sir, anything can generate work. Let's see. Let's see the third example. Let's take an example of a pendulum motion. Which kind of a motion? Pendulum. Okay. See, in this pendulum, let's say this is the vertical direction. Okay. And at some time, there is a thread attached with the block of mass M. What or not? Which is placed over here. Now question arises, at this instant of time, this is making angle theta. So when it is oscillating, what forces are acting and what is the work done? Can you measure it? Let's try to see. Someone asked you what is the work done by the tension. They asked you what is the work done by tension force. To talk about that, simple idea is there. First, I'll draw the FBD of this, correct? To talk about any kind of a force, I'll draw the FBD. This is the direction of tension. This is its weight, how much? mg. Assume that over here it has started to move. Now look over here, this is tension and this is mg. Now when this body will oscillate, this body is going to oscillate in some like this manner or not. Say something is no. So when you are going to look into the displacement factor, the displacement is going to be in which direction? This displacement is going to be in this direction. Are you able to get me or not? Correct. This is which direction? Direction of displacement. So you can see that this tension is making how much degree with the displacement? 90 degree. So therefore what I'm going to write, that work done by this tension force is basically how much, Balak? Is 0. Okay. Why? Because this tension is perpendicular to the work done. Are you able to get me? This tension is what, Balak? Perpendicular to my work done. Is that clear or not? Perpendicular to my displacement. What I'm writing? Where is my mind? Now, as I got to know that this work done is perpendicular to the displacement, first factor is clear. Second factor arises that, sir, this means that you can see that when a body, this kind of motions are basically like circular motions, correct? So I can create third point of the work, that if you can see that any kind of a radial force is present, if any radial force is present, then its work done is 0. Then its work done is how much, Balak? 0. Are you able to get me or not? Say me something, yes or no? That's a very nice question. What is a radial force? Basically, if a body is doing any kind of a circular motion, so then there are some forces, like this one was doing circular motion. There are some forces which are present along the direction of radius. So there are the forces, you can say, the forces present along the radius of a circular track, or along the direction of radius in a circular motion. Circular motion, or you can say elliptical motion. Those are basically called as radial forces, and their work done is almost going to be how much? Always 0. Is that clear or not clear? Are you able to get me on? So let's take an example. We'll do one example. Imagine that there is a block of mass 2 kg, and I applied a force of 10 Newton on this. Okay, or let us little bit have a little bit twisted question. I applied a force like this way. Okay, and this force is, but let me just draw it properly. I think so. and this angle is given as 37 degree. Question is, find the work done in time t is equal to 2 seconds. Find the work done in time t is equal to 2 seconds. $64. Let me check. हरिओम बना है? क्या हो गया हरिओम? सो रहे हो क्या? So this force is how much? 10 cos 37. How much is that? 10 into 4. How much is that? 8 Newton. Correct. Now look over here. There will be, of course, there will be some displacement along this direction. Correct. Now, mm, if there is a force, then there is some kind of acceleration along this direction or not. Okay. Now, question arises: how much is that acceleration? To find this acceleration, see, first of all, we can see that the accelerating force is how much? 8 Newton. So therefore, acceleration will be what? Force applied, which is F cos 37 divided by mass M. How much is that value? Basically 8 by 2, 4 meter per second square. So therefore, I can find the displacement in 2 seconds or not. Displacement in time t is equal to 2 seconds. So that is how much? Simply S is equal to ut plus half at square. Assuming that initial velocity was 0, so half acceleration is how much? 4 and time is how much? 2 square. So basically this is how much? 2 cancel, 8 meter basically. Are you able to get me or not? So therefore, work done by this force in t is equal to 2 seconds. That is going to be how much? Simply work done is equal to force dot displacement, and that is force is how much? 8 cos 37, because this is the work done by the force, because vertical component is making how much work? Basically 0. Means this F sine 37, if I look into that, F sine 37, this is what? Perpendicular to displacement or not? So therefore, its work done will be how much? 0. Are you able to get me or not? So this will be 8 cos 37 into displacement 8, which is, how come it is 64, Arpit? 8 into 4 by 5 into how much? 8. Oh, okay. Force is 10. Okay, sorry. Hmm. 10 cos 37. So this is how much? 5 twos are 10. That is 64 joules basically. Are you able to get me or not? Is this clear? Okay. Let's try another example. Okay. Now let's suppose there is an inclined plane. Okay. And a block of some mass is placed over there. Okay. Now this question is going to be good. Okay. And who's going to say? Hi Ryan. Hey, Harpreet. Good evening, Rehan. But how do you got to know about this thing? Abhiraj told you or what? But no one should be aware of this. Why or not? Ah, ah. Now look over here. So we are doing some questions, and let's suppose there is a block of mass. Okay. Let's suppose this block is of mass. How much kg? Let's take 2 kg, 5 kg. This block is placed on an inclined plane, and the inclination is of 37 degree. There are wheels attached to this inclined plane, and this inclined plane is basically moving. Right or not? These inclined planes are basically moving, and it's moving with velocity. How much? It's moving with velocity, let's suppose 4 meter per second. Right or not? Or I can optimize this question. Wait, let me just make this question a little bit much more crystal clear. Let's suppose this inclined plane is on a truck. Okay. And this truck is moving with some velocity. Now it will be much more clear for me. Okay. Let's suppose Anurag sir is driving it. Right or not? And it's moving with velocity how much? 4 meter per second. There is this inclined plane, same thing like the earlier, 37 degree, and there is a block of mass 5 kg over here. Okay. The surface is rough, keep that in mind. Okay. Means this surface is basically rough. I don't know friction, I don't know. But what it is saying, that question is saying that let's suppose there is an observer. Okay. Who is standing over here. Let's call this as observer B. And another observer is there. Okay. Who is on the ground. And this is observer A. The question typically says that with respect to observer B, the block is at rest, then find the work done in t is equal to 2 seconds with respect to question number A, observer B, question number B, observer A. Do this question. This is your question. Think about it and tell about it fast. Okay. Uh-huh. Why? Correct. With respect to observer A. Yeah. What will happen with respect to observer A? Do that. Acha, I want to talk about this a little bit in depth. Okay. This pseudo force. Uh, See, keep that in mind. This is called as, again, this trick which I am writing over here, it's called as ATH. Okay. Do you know what is full form of ATH? Ryan? It's called as Anurag Sir theorem. Okay. Let's suppose, understand this scenario. हरिओम इसको सुनना ठीक है. Hello. Let's suppose there is a car, okay, which is accelerating and which has some velocity v also. Okay, and two things are happening. A block is there in this frame. Okay, block of mass m, and another one, someone throws one particle over here from this frame. Okay, got it or not? Same mass m. Tell me, on this mass and on this mass, what and what thing will be transferred? You don't know it? Let me explain it. See, basically, if there is an acceleration, if there is a velocity, so although it will be treated like a non-inertial frame, this will be treated like which kind of a frame? Non-inertial frame. Any accelerating frame is called as non-inertial frame. Okay, any accelerating. And we know that in that, the particles inside that frame will feel a pseudo force. Now, question arises, what is that direction of pseudo force? So that direction of pseudo force is, it's basically this magnitude of pseudo force. I'm writing it as Fp is always equal to mass of the particle into acceleration of frame. That's the biggest point. Acceleration of what, Palak? Frame. That's the value of pseudo force which will act on the particle. Same is something else. But see, this idea of non-inertial frame is only present because I'm looking, means this non-inertial frame is present with respect to an observer in the frame itself. Means let's suppose this car is there and on the ground, here there is Rayan and here there is Abhiraj. Hold on. So this mass will feel a pseudo force. Understand the forces which I'm drawing. If I try to draw the FBD of this mass F, okay, let's call this as capital F, okay, such that we can have a clear idea. Let's suppose if I want to draw the FBD of mass M with respect to Rayan and with respect to Abhiraj, right or not? So look over here, with respect to both of them, see, Abhiraj will be called as, means this A observer will be called as which frame? Non-inertial frame, because it is in present in which kind of a body? Accelerating body. Keep that in mind or not? With respect to A, this mass will feel a pseudo force. This mass is going to feel which kind of a force? Pseudo force, and that force is equal to what? Mass of the particle into acceleration of the frame. Let's suppose it is called as a naught, so it will be m. Same something, yes or no? Are you able to get me or not? But if I consider this ground observer, with respect to ground observer, the car is still going towards right hand side or not? And what you will see? You will see that the mass is also going towards right hand side. How it means? You only see me when you are sitting on a ground and you are observing that some person is there in the car, and that car is. Let's imagine a bus situation. There is a bus, and you are sitting on the ground, and there are some passengers over here. Bus suddenly accelerate. What this ground observer will see? Everyone is going in forward direction or not? Saying something, yes or no? But other passenger in that bus will see that no, car is going forward, but the other persons are going in backward direction or not? Correct. So see, the idea of pseudo force not does not appears due to ground frame. It will appear due to, means the observer must be in the accelerating frame itself. Are you able to get me or not? So pseudo force ma naught will appear due to this A observer. But if I look from the ground, this ma will, this mass m will feel like it is accelerating in forward direction with the force how much? Ma naught itself. Are you able to get me or not? Clear or not? Okay, so look over here. See, this is what I asked you over here. This is not an accelerating, that is still it is inertial frame. Any constant velocity frame, like one day I'll talk about this inertial and non-inertial frame in a great detail. I'll write the equations, but right now we'll just focus on this. Okay, what we can see that if any frame is moving with constant velocity, then we treat such frames as inertial frame, and in that means pseudo force does not appear. So are you able to get me or not? Now if I look with respect to observer B, first question, with respect to observer B, now what is going to happen? Simple idea is that displacement is 0, so this implies that work done is also 0. Saying something is no. But with respect to ground, you will feel now that as whole thing is moving towards the right hand side, this body mass 5 kg is also moving towards right hand side along the direction of velocity. Correct or not? Saying something is no. If I draw the free body diagram, this is what? Normal n. This is weight of the body, and this is 37 degree. Now question arises that how this body is at rest. See, this body is experiencing, if I resolve this mg, then this mg has two component, correct? This is 37 degree, this is 5g, and this is 5g. So this is how much? 5g sine 37 is how much? 5 into 10 into 3 by 5. How much is that? 30 Newton. So basically, if this body is at rest and nothing is mentioned, that means that there is a force of frictional force is acting in opposite direction, and that must be equal to mg sine theta or not. And with respect to observer B, which frictional force will act? Static frictional force will act. See something, yes or no? Because F limiting is mu into n. Are you able to get me on? So if I try to draw second point with respect to observer A, how to find work done by friction? With respect to observer A, we can see that the particle is experiencing a friction force in this direction, and there is a displacement along right hand side, correct? And this frictional force is having a value, and that is equal to how much? 30 Newton. Got it or not? And this displacement is equal to how much? 8 meter. So work done will be, if I can find Huh? 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 See, with respect to B, it will not feel to be moving. But with respect to A, whole thing is going along right hand side, so the block will also feel to move along right hand side or not. Got the idea or not? So time is how much second? Time here it is saying 2 seconds. So displacement it will do how much meter? Speed into time. 4 to the 8 meters along right hand side. Are you able to get me or not? Now look over here. This is 37. This angle will be alternate interior. So this will be also how much? 37. Total angle is how much? 180 from here to here. So this angle is how much? 180 minus 37. Is that clear? So this why I'm writing over here 180 minus 37. So therefore work done by friction with respect to observer A is how much? Simply uh, frictional force, which is basically static into displacement, and that is cos 180 minus 37 degree. So this gives us a value. If a static is how much? 830 we have calculated, but and as you know, cos 180 minus theta is minus cos theta, so I'll write it directly over here. So 30 into 8 into 4 by 5. 5 6 are 30. How much is this? 48 into 4 minus of how much joules is this? Tell me. Huh? Positive, how come it will be? Minus. Huh. I think 208 or 228. 192 joules. Clear or not clear? So this gives us a large big conclusion over here. Of course, negative sign. Frictional force is making an obtuse angle with the displacement. So this means that there will be a negative sign. Okay. And work done should be negative. You only think that something is kept in a something is not moving over here. So if nothing is moving over here, then of course the work done will be what? Negative with respect to A observer, because this body is at rest, but it is at rest in opposite direction due to F static and in forward direction due to G sin theta. Are you able to get me or not? So work done by G sin theta is positive and work done by F static is what? Negative. Are you able to get me or not? And work done by normal is also there over here. Send me something as well. So of course work done, does this means that any scalar quantity will not have negative value? Any quantity can have positive, negative, zero. Any scalar quantity. There are some specified scalar quantities whose values cannot be negative. Like current. Current is a scalar quantity whose value cannot be negative. Are you able to get me or not? Is that clear? Mass is a scalar. Time is a scalar quantity, but its value cannot be negative. So there are some quantities whose value you cannot generally say that all the scalar quantity will always be positive. No, it's not like that. Some of the quantities scalar are positive, some of the quantities scalar are negative, some of the scalar quantities are zero also. So there were three conclusions earlier. Now this we get as a fourth conclusion. We found out that work done, if I use work done formula is equal to force dot displacement, then this is frame dependent or observer dependent equation. So fourth point what we got, that our work done is either frame dependent or observer dependent equation. Are you able to get me or not? This is clear or not? So my plan is today my health is not that much good. So what is my plan, that I'm keeping it till over here only. Okay.